Example 4. We're going to look at, of course, our leading coefficient. What is that sign there? That is a positive. Then we're also going to look at what is our degree. Our highest degree here is 4. So when I'm looking at this, first I want to check x to the 4th minus 3x cubed plus 2x squared. I can go ahead and factor out an x squared. So I'm going to pull out an x squared, and I'm left with x to the 4th, x squared minus 3x plus 2. So at this moment, I can take each part and set it equal to 0. So I get x squared equals 0, and I get x squared minus 3x plus 2 equals 0. And if I go ahead and factor this, I get x squared equals 0. That doesn't change. This factors into x minus 2 and x minus 1. Set those equal to 0. So I get x minus 2 equals 0, which is x equals positive 2. And then I set the second one, x minus 1 equal to 0, and I get x equal positive 1. Well, looking at these, I know that these are classified as linear functions, just based on how they looked. However, if you look kind of down here at the bottom, I have x squared equals 0. X squared deals with this polynomial that is a parabola, so we call this one a quadratic. So it has that quadratic look to it. Well, based on my leading coefficient being positive and my degree being even, let me change that from 4 to just saying even, we know that our graph should face up like this on both ends. So I'm first going to go ahead and plot my points. So at the origin 0, and then I also want to look at, well, let's go ahead and rewrite this as x equals 0. That's what happens if you factor it. 0 and then positive 2 and then positive 1. So right on top of each other. So I'm going to look at this as knowing from the quadratic portion of it, seeing that they all face upward. I'm going to come down here and just so notice how that's a parabola because it starts at the quadratic being x equals 0. Then I'm going to that the rest of these graphs are linear. So from here, I'm just going to curve up and come down. And then I'm going to scroll down a little bit and come back up. Notice here that you have a parabola kind of here, and then eventually you start to see the line form for these other graphs. So this is our our linear, and then in yellow we have our quadratic. So let's get another one. Example 5, again, go ahead and write out your leading coefficient and what that term is, what that sign is. That is a positive. So I'm going to look at the degree. The degree is an odd degree. Oh, no, we could. Okay, so I'm going to go ahead and take example 5 out. That one is really, really ugly, and I'd rather show you all in person than over a video. So for example 6, notice that we have a set of x values, and then notice how we have a square here for x squared. So I just want you all to consider what is getting ready to happen here and how many x values we have. So we have x to the 3rd plus another x, that's 4, plus another x is 5, plus the fact that we know that there's going to be 2 x's here because if I were to FOIL it, I'd have x squared. So I ultimately have x to the 6 if I were to rewrite this and FOIL it. I'm going to start with my leading coefficient. That's going to be positive. My degree here is an even degree because it's going to be 6. And when I look at this, it's kind of already broken down so I can set it equal to 0. So I'm going to go ahead and do that. I'm going to take x to the 3rd, set that equal to 0. And when I solve for it, If you want to go ahead and take the cube root of both sides, you get x to equal 0. Then I'm going to look at the second part that says x plus 2. Set that equal to 0. I get x is equal to negative 2. So right now I'm going to write linear and linear because I already kind of know those shapes. And then I'm going to look at the last one that says x minus 3 squared and set that equal to 0. Remember, solving this, I can go ahead and take the square root of both sides. Those cancel. And I'm left with x minus 3 equals 0. So I get x is going to equal positive 3. So also by looking at this, I know that at this moment, x equals 3, because this value was squared here, I know that this is going to be a quadratic type equation because of that square there. Tells me that I have two sets of 3's going on. Both of them are positive 3's. So when going to graph this, remember the shape that I should be looking for is something that goes like this on one side and up on the other side. So first, my point, x equals 0, x equals negative 2, and x equals 3. So the first one I'm going to look at is the fact that from negative 2 first, x is going to be a linear function. I can go ahead and start from the top and come all the way down, kind of curve up. So when I get to 0, I know 0 is also a linear function. So I'm going to go ahead and come here, a line. Well, I also know that with this value here, let's come up. Well, at the value of 3, value, I'm going to just up around the So because I know both values are upward, this is how I graph my graph and set kind of make it look like that. So it's not exact, however, it kind of gives you a little bit of an idea of what happened. So I'm gonna highlight everything. So our linears are in yellow. So this takes care of our linear, and then this how I have my quadratic, which is in green, kind of flows right about here. Turns into a quadratic. So linear, linear, and then a quadratic. Make sure you all read these from left to right and how you graph it. So how to graph is going to go from left to right. Okay, so let's talk about our local max and our local mins. So here for local max and min of a polynomial, if p of x equals this equation, the polynomial of the degree n, then the graph of p has at most n minus 1 local extremas. So when I look at this local maximum point, it's simply what is the highest point of the graph. And our local minimum point is what is the lowest point of the graph. So you can have a high or a low depending on what your equation is and how many curves you have. Okay, so the last example says graph the polynomials on the graphing calculator and determine how many local maxima and minimums it has. So here, if you look off to the right for A, I already plugged in the equation. So I'm going to go ahead and graph that. And if I look at my graph, notice that it kind of crosses twice. So for this graph, I'm going to go ahead and kind of sketch it out. I know that it does this, kind of comes down a little bit and goes up. So I know I'm going to have a local max and a local min point. So for my local max, I'll kind of figure out if we can find this. So I'm going to go second trace, go to the max, number 4, left down just a little bit, go over to the right down, again to the third one. Hopefully that I have a local max at x equals, so I'm going to go ahead and write it as f of negative 0.33, and that's going to give me about 0.1851 or 2, rounded up. So that's where my local max is. Same thing for our local min. Second trace, go to minimum, which is our third position. You're going to scroll over and you're going to go left bound equals, do a little bit for the right bound, enter, and press enter again. And that tells me that for my local minimum value at f of 1, basically, equals -1. For B, see if you get these local max and mins to be none. Your graph should look like this when you sketch the graph. Double check it, see if that's what you get. We're not going to do example 8 today, but if you have any questions, please highlight them and you can begin working on your 3.2 homework.